our discussion regarding the another protein separation method, that is 2D gel electrophoresis method. So here we are using another electrophoresis method to separate protein, right? So 2D gel electrophoresis. So the term 2D means two dimensional. Okay, so this method was first developed by O. Farrell and Close in 1975. This method separates proteins on the basis of two properties. One is isoelectric point, another one is molecular weight. Okay, so in each dimension we are using one electrophoretic separation technique, especially designed for protein, right? So in case of first dimension, we are using isoelectric point under consideration. We are using isoelectric focusing that we have discussed in our previous video. And in case of molecular weight, we are using SDS page that we have discussed also. Okay, that means 2D gel electrophoresis is the combination of both IEF and SDS page. And here we are going to learn how we will attach the first dimension separation, that is isoelectric focusing, and the second dimensional separation, that is SDS page, together. Okay, so this method was introduced by O'Farrell and Close in 1975. So first of all, I have already discussed about how pH of the environment determines what will be the charge of the amino acid and subsequently what will be the charge of the protein, right? If the pH is acidic, the protein will be positively charged. If the pH is basic, then protein will be negatively charged, right? So an isoelectric point is the pH value at which the protein will have net neutral charge. That means number of positive charge will exactly equal to the number of negative charge. So now let's move to the direct discussion, because we have already discussed about SDS page and isoelectric focusing in two separate videos. Then I will recommend you to go and watch those videos first and then come back here if you have no idea about what is SDS page and IEF and you have come here. So that will be helpful to you. So here first of all we have protein extract. Here we have our protein extract. So our first job will be to perform isoelectric focusing. Okay, so here we are using a strip that are of various pH gradient. So the common strip that easily available in the market and we are using for performing isoelectric focusing is IPG strip. The pH normal most common pH gradient of IPG strip is pH 3 to 10. Okay, so pH 3 to 10. Our first job will be to pour our protein sample in the isoelectric in the IPG strip for isoelectric focusing. Okay, then once we have poured, we will transfer the IPG strip in a machine that will provide the electrical charge necessary for separation. Okay, so how the separation will going on, I am again going to mention, although I have mentioned it in the isoelectric focusing video, but still I will going to mention. Suppose let's consider that this red molecule is in a environment of pH what should say 8. Okay, but the red molecule's pi is 5. Okay, that means what, it is in a basic environment as compared to its pi value, right? So what will be the charge? As I have told you that in case of basic environment, the amino acid have negative charge and concomitantly the protein will also have negative charge. Okay, so it will naturally migrate towards the positive electrode, and during its migration it will find a pH value which is exactly equal to its pi, that means 5, right? So in that particular point it will carry no neutral charge, that means number of positive charge and number of negative charge will be exactly equal to 0 or exactly same. So in that point they will not migrate further towards any of the electrode and they will eventually stop there and fix themselves there. And that is how isoelectric focusing separate proteins on the basis of their pi value. Okay, And if suppose I am again discussing one for positively charged protein, suppose this one, okay, this one is in a environment of pH 2, no, sorry, pH 4, okay, but these have pi value of 8, okay. That means as compared to pi, the protein is in a acidic environment, so naturally it will have positive charge, so it will migrate towards what, sorry, let me take the color, it will migrate towards positive electrode, negative electrode, okay. And during this migration it will find a pH value which is exactly equal to the pi, and it will stop there immediately, as in that point the net charge is 0, right, because all the positive charge is exactly equal to all the negative charge. So that is how isoelectric focusing separate proteins on the basis of their pi values, okay. Now we will put our IPG strip horizontally over the resolving gel, okay, to perform SDS phase. Remember one thing, as our proteins are in same line, right, our proteins are in same line here, so we don't require any kind of stacking gel preparation to perform SDS phase, right. But if you want if you want to perform stacking gel also, you can, but there is no requirement. So this is the resolving gel. So resolving gel will be prepared by the same way as we have discussed in our SDS gel electrophoresis technique. You can easily consult that video to know how resolving gel is prepared. Although here the pH value will be 8.8 to 8.9, and the concentration of acrylamide will also high, 5 to 15%, okay, along with APS and TMATE for cross linking is also there. So then we will apply the voltage and they will separate the protein on the basis of their molecular weight. Now let's look these two, okay. They are of same molecular weight on according to the SDS phase separation, right, as they have same band. Here we will have a marker that will guide us about the molecular weight, right. So these two protein have same molecular weight. Now the question is, so as they have widely separated with the help of SDS phase, then why we have performed 2D gel electrophoresis? So remember one thing, if we do not perform isoelectric focusing, we will directly apply our protein sample in the SDS phase, then the orange molecule and green molecule will give you only a one overlapped thick band, okay. And with the help of this thick band you cannot make out anything, right, because you cannot separate those two bands, right. So for most sharp separation we have to perform first isoelectric focusing to separate protein on the basis of their molecular weight, and then we will start our SDS phase, so that the proteins which are of same molecular weight can be easily separated with the help of 2D gel electrophoresis. And that is the utility of 2D gel electrophoresis, right. Here we are performing a first dimensional electrophoresis to separate our protein on the basis of pi first, then the second dimensional electrophoresis to separate our protein on the basis of their molecular weight. So that is the basic concept regarding the 2D gel electrophoresis technique, okay. So the question will come on the basis of case studies here mainly, that they will tell you that suppose you are a microbiologist in your hospital and there is a patient who is infected with disease X. The protein that caused the disease or the antigen that caused the disease is A, which is of same molecular weight with another protein, that is normal protein present in the serum, okay. Then how can you separate A from B? So as I think you should go for I think that you should go for Western blotting technique here, right? You will simply develop a antibody which is specific for the protein A, right? But still, this kind of technique can also be separated with the help of our with the help of our 2D gel electrophoresis technique, right? And then after completion of the SDS phase, you will stain them with the help of comassive brilliant blue. That is how the separation technique is going on. So you can take the screenshot of the notes so that you can prepare them well. Here these two line is important. The separation, the first dimensional isoelectric focusing of 2D electrophoresis, and second dimensional SDS page of 2D electrophoresis. Okay. This line will be, this is the wrong. Here we have to write SDS, 2-dimension SDS of 2D gel electrophoresis. So that is how two protein of same molecular weight can be separated with the help of 2D gel electrophoresis. So that's it for today, guys. I hope that this video will be helpful to you, and if it is, please hit the like button, share with your friends, and subscribe to my channel to get more videos like that.